Okay. So it'd be log 2 and then 9 equals 3.
Let's see. Log 2.
Oh no, yeah, it would be the larger number wouldn't. Oh yeah, it'd be log 9 and then 2. As in like log as the smaller number is 9, right?
Let's see. So the base. So this is the base, this little one. And so you have like base and power.
Wait, is it log 3?
So it's going to be log, I believe you say log 9 base 3.
Okay.
And that's equal to 2. Yeah, that's it. Okay. B.
Log 128 base 2 equals 7.
That's it. And C.
Log 8 base 64 equals a half.
Well done. That's it. In words, you would say the logarithm of 9 to the base 3 is 2. So yeah, log 9 base 3 equals 2. Yep.
Yep.
Or to the base 2. Okay, and in reverse.
Okay.
And you can do using that kind of...
So would it just be 8? Wait. So it'd be. I don't. So it'd be 4 on the left.
3 is the base.
Okay.
And 4 is the power. So let's go like there, there, there. And so it's like big 3, power 4 equals 81.
Okay. Okay, yeah.
Okay, question B.
Okay. 2 to the power of minus 3 equals 1/8.
Yep. 1/8. Great. Okay, without using a calculator. What is this? And if it helps me, I would do log 81 base 3 is equal to x and solve for x basically.
Okay. So is the base 3, is that the power? Or is the x the power?
X is the power, 3 is the base.
So 3 to the power of x equals 81.
Yeah.
And then can you divide by 3 on both sides?
Essentially, you'd have to log both sides because that's the opposite. It's not divide by 3, or it's not times by 3. But basically just 3 to the power of what gives you 81.
4.
Yeah. And so this is just intuition. But the actual method would be to put, like, to do that.
Yeah.
Okay, B.
4 to the x equals 0.25.
Yeah.
So would x be 1/8?
Well, 0.25 is the same as a quarter. Any idea about that? 4 to the power of what is the same as a quarter?
4 to the power of a half.
That's the square root. What power makes 4 over 1 become 1 over 4?
Pardon?
What power makes 4 over 1 become 1 over 4?
-1.
Yep. Power is -1, x is -1. So this is just kind of for intuition more than anything. C.
So it'd be 0.5 to the power of 4 equals x.
To
to the power of x equals 4.
Yep. And I'm going to write that as a half. So a half to the x equals 4.
It'll be 4. X would be 4.
I think that would give you... no. 4. Let's see. So 4 is the same as 2 squared. And that's the same as a half to the power of what?
Okay. So it'll be 8 then.
Hang on. So 2 over 1 is equal to 1 over 2 to the power of what?
-1.
And so 4 is the same as 2 squared. 2 is the same as a half to the -1. And so 2 squared is the same as a half to the -1 squared. Power to a power, what do you do there?
-2. Oh, you add, wait, do you multiply or add them?
Multiply.
So it'd be -2.
And so a half to the x is equal to a half to the -2. By inspection, what is x?
-2.
Yeah, x is -2. And D.
So it'd be a to the x equals a to the 5.
Yep. X equals?
5.
Yeah. That's it. Yeah, so you can see it's just building it up. But what you would really do, but this will be good for later. Menu. You would do log base is 3. This is 81, and you get 4.
Yeah.
So that's what logs are. If you're in this situation, 3 to the power of x is 81. You're saying, oh, you divide both sides by 3. Actually, you write it in log form. Is the opposite of an exponential.
Yeah.
That's it. Why are you yawning? You up late or something? You're probably on these Zoom calls all day at school and stuff. These ones, you just put them in your calculator. Try this question B. It's a bit weird.
In the calculator or just by manually?
Calculator. These are calculator.
So instead of so is that E or is that a C? That's an E, right?
That's an E.
Okay.
So how do we do that?
Could you sub it as X?
No. Calculator. Do you know where E is?
Yeah, it's next to log, but it's shift.
Yeah, I'm concerned. Do you have to do? I think you have to just do e to the power of 1. That's
Okay.
how I do e.
And then you'd put 8 in.
Do you get the same thing?
Yeah.
So older calculators don't have that automatically e to the power of something. It's just e, and you have to put it to power. So the way you get around that is to the power of 1.
Yeah.
I think that's what I'll say about that. It's because log to base e is kind of special, but we'll get there. Hang on a second. Yeah. Stick that there. 2.079. Okay. Right, exact value. Let's try this one.
I got X as 16.5.
That sounds good to me. How'd you get that?
I put in the calculator log 8 and then brackets 2x minus 1 equals 5 over 3.
You sneakied me. That's a good way of doing it. So, what would I have done? 8 to the power of 5 over 3 is equal to 2x minus 1. Yeah, so maybe x equals 8 to the power of 5 plus 1 and then all over 2.
Yeah.
So just in case. Okay.
Yeah.
Let's see this one. I have a feeling that this one will give you some easy answer as well. So I think you'll be fine. Let me just compare that. So this one x was there. This one this will give you another easy answer. What would this be? How would you write this as an equation?
So for this, would you do, so x is the number, right?
Yep. The base.
So it'd be x is equal to, or it'd be x to the power of 3 over 4
Yeah.
is equal to 64.
Yeah. And how would you usually go about solving that if you had like if you had to do it manually?
Could you do root 4 for 64 and then multiply by, and then square it by, cube it by 3?
Yes. So it's basically the 4th root of 64 and then cubed.
Yep.
And that'll work out 256. Okay. This time x is that number, the answer. These all just seem to be working out though. The calculator would take care of these. So what would this one be then as an equation?
125 to the power of minus 4 over 3 equals x.
Yeah, and so this is the type where that would just go in the calculator, because 125 to the power of minus 4 over 3 is the whole thing. Yeah.
Yeah.
It's saying an exact value. I think these will become more important later on.
Yeah.
Yes, this is the one that you can't use a calculator for. Okay, how about this?
Okay. So would you write it out as a to the x?
Yep.
A to the x is equal to brackets 3 root a squared, close brackets.
Yep.
And then does that simplify down to just a?
Write it in index form.
Oh yeah, okay. So it'd be minus a half and then cubed, square rooted, the cube rooted.
No. Cube root of a is the same as a to the power of what?
A third.
And so, if that is
Or it'd be 2 over 3.
Yeah, exactly.
Yeah.
So that'll end up being 2 over 3. And so what is x?
X is 2 over 3.
That's it. Okay, that stuff.
That was easy. I got tick probably.
Great. Okay, laws of logs. I'm going to skim this. So basically, let me just go back. A logarithm is a power. That's what it is. You know, we have like this whole thing is equal to x. and then
Yeah.
we rewrite it as a to the x. X is the power. This whole thing, this logarithm is equal to x. This is a power. When do you see two powers being added?
When there's x and y.
So let's say you saw the second half of my question and it said x to the 2 plus 3 and then x to the 5. What was the first part?
Oh, it must be x squared times x cubed.
Yes. And so you add, if you see logs being added, you multiply. You multiply the two. I don't know what to call those.
Okay, indexes. You multiply the two indexes.
No, they're not indexes. They're usually just the
Oh,
answer.
the number. All right, yeah.
Yeah, all right. Let's go with the number then. I used to call it answer, but it's just
So
confusing.
x and y.
Yeah. So
Yeah. Okay.
yeah. When do you see logs being subtracted? Sorry, when do you see powers
So you
being subtracted?
divide then if it's subtraction.
Yeah, you see, if the powers are being subtracted, that means that they were divided.
Yep.
When do you see power to a power?
So for logs, does that mean it's adding? Because normally power to a power means you're...
No, sorry, my mistake. When do you see two powers being multiplied?
When there's one outside a bracket and one inside a bracket.
Yeah, power to a power.
Yeah.
And so if you have power to a power, you multiply. Okay, I think that's how that one works. The rest of them are just kind of what you would expect. You can do it the long way. Like 1 over x is the same as x to the minus 1. And then and you go from there. The other one is a to the x equals a. It must be to the 1. And then a to the 0. If the answer is 1, then it must have been something to the power of 0.
Yeah.
So we'll try to put these together, but it's a lot. Okay. And a bit like x and y, they have to have the same base, but they usually have the same base. In the first one, the base is 3 for both of them. So
log 3, 42.
Great. B.
Log 2, 5.
Yeah, C.
So for this, do you multiply the number on the outside as well?
In this case, then it doesn't work if it's like 2 log, 3 log. It has to be log and log, like log plus log. The way you do that is, when do you see powers being multiplied? When
they're the same.
When do you see... let me go back. Yes. Remember this one where we got to the minus 2?
Yeah.
We multiplied them.
Yep.
Why was that? That was power to a power.
Yeah, those two.
So power to a power. The implication of that is you can rewrite that as to the power of. And so instead of 2 times log 3 base 5, it is log 3 squared base 5. So if there is a power, you can bring it to the front and multiply by the whole thing.
So you have to work out both sides of the plus separately and then add them together.
Yeah.
Okay. So it'll be 9 for the left.
Yeah, so that was going to be log 9 base 5.
The other one will be 16. Log 5, 16, right?
That would be 2 to the 4. 2 to the 3 would be half that.
8.
Yep. So that one is log 8 base 5. And
So it'd be log 5, 72.
Well done. Great. And D is similar.
Okay. Can I use the calculator for this?
The purpose
So
of
the
the
half to the power of.
yeah, do a half to the power 4 on the calculator, but just that.
It's -4, right? Or is it
Uh,
just 4?
just 4.
Okay. Well, that'd give you 16. Well, no. 1/16.
Yeah. So that's log base 10 3 log base 10 1/16.
And then 3 divided by 1/16 is 48.
Great. And so final answer is?
Log 10, 48. Or log 48 base 10.
That's great. And I just want to see if we actually have to think about this or if your method will also work. What would it be if you did plus log base 10? What is a half to the -4?
1/16, right?
To the -4?
Oh, -4, 16.
Yeah. And so 3 times 16?
48 is the same answer.
Yeah, same answer. Okay, so we don't have to worry about it. So even if you bring up the -4 and that becomes plus, it'll work out. Whichever you're more sure about. Okay, but
yeah.
So in reality, these are just numbers. You could put this whole thing into your calculator. The problem is, let me just see part A. Log 3. Log 6 base 3. Log 7 base 3. We get a decimal, and they asked us for an exact answer. And so we could put it in the calculator and then just check our final answer. So our final answer was log 42 base 3. And it's the same number. And so we know that we got it right, but we can't get it just with the calculator.
Yeah.
And then these ones we definitely can't use calculator. Okay, let's try these. This is now working in reverse. So it would be like if you were given log 42 and you had to break that into log 6 plus log 7.
Okay.
You have to break this into log x, log y, log z, not one log.
So it would just be log x, wait, 2, no, it'd be x log 2.
What answer are you sure of before we simplify anything?
What do you mean, like, sure of?
Like, I think you're trying to do two things at once. Let's see. Let me see. Try question B.
Okay. So would you simplify that into a root?
No. Don't have to.
Okay. So would it be y on the... No, it'd be 3 on the left. So it'd be 3 log a x over y.
Nope. Let's see. There's no better. It's the opposite of part B of this one. So part B, log 15 minus log 3 is log 15 over 3.
Okay.
So you can bring them together. You can also bring them apart. And so log x over y cubed, what's that? As
log x. Log ax.
Yeah.
Minus log a. Oh, would it be
Don't just
y?
What answer are you sure of?
Okay, log a y cubed.
Yes. And I'm not sure. I think they might ask for... Yeah, go on. What would this one be then if you rewrote the second part?
Would it be 3 log ay?
Yes. I'm just seeing. So that's in terms of log y, 3 log y, whereas y cubed isn't. Yeah, so you have to do it like that. Okay, same idea, part A, and you don't have to do it all in one go. Or you can if you insist, so long as you get it right.
Would it be 2 log ax plus log ay
Mm-hmm.
plus 3 log az?
Yep. Let me just make sure I'm not. Yeah. So it's better to put the power at the front.
Yep.
Okay. C.
So would you rewrite y to the power turn it into like a power to the x to like the power?
And so that would be the same as y to the power of what?
A half.
Yeah.
Okay. So you'd write it out as log ax plus a half log ay. And would those be in brackets?
Nope. It's fine.
Okay. And then you do minus log az.
Yeah. Brackets wouldn't hurt, but they're not necessary because adding and subtracting doesn't matter what order. Multiplying and dividing doesn't matter what order. And let's just do D for good measure. I think you'll be fine with it.
Log ax
I'm just making a note to myself. Yeah.
Okay.
Log AX.
Log ax minus 4 log a.
Yeah, that's weird. Hang on.
Yeah.
Let me just think about this. Log A base A is equal to X. Put this into index notation. Index form, what would it be?
I'll put it into index form. Okay.
Yeah.
So will that be x to the power of a equals a?
I believe it would be like that. A to the X equals A.
Okay.
A by itself is the same as what?
A to the 1.
Yeah. And so what is X?
1.
So X is 1. And if we go up to the top, what else was X equal to?
A.
It was equal to log A base A.
Yeah.
And so log A base A equals 1.
Okay.
And so that is 4 times that is 4 times 1. And so final answer.
Minus 4.
So that's minus 4. And don't forget this bit.
Log ax.
Yeah. What did we just prove there? We just proved that log anything to base itself must be 1.
Yeah.
Yeah. So if you ever see like log 5 base 5, let me just check that. Log, lucky 7. Yep. Log anything base itself is 1. Yeah.
Okay.
Because anything to the power of 1 is itself. Okay. Great. Good. We're solving equations. Hold on, before we do that. Are we solving it? Huh. Yeah. I organized this pretty well. Not gonna lie. Alright. It is equation time. How are we doing this?
So is the equals 2 part of 2 log 10x equals 2?
No, it's just like left side is equal to right side.
Okay.
Basically, there's like invisible bracket around x. They just don't bother putting it in.
Okay.
Your calculator will have it. We'll
Okay.
see.
So would you multiply? Would you do 2 times? Wait. It would be x to the power of 2.
Yeah. So you could bring that like that. Okay.
And then could you multiply them?
Yeah. What would you get?
4x squared.
Yeah. So it would be log base 10 4x squared equals 2.
And then you'd make it. Is it 2 to the power of 10?
Why do you always do that? So little.
Oh, no, it would be 10 to the 2
Yeah.
equals 4x squared.
Yeah. And then you solve that as normal.
Yeah. And then you can square root both sides.
And what would you get?
10 equals 4x.
You'd actually get 10 equals 2x because you'd have square root 4 as well.
Oh,
Divide both sides by 4 first.
okay. So you'd get 10 over 4.
10 squared over 4.
10 squared over 4
So do that.
equals x squared.
Yeah, so you divide before you square root. What's 100 divided by 4?
Pardon?
What's 100 divided by 4?
25.
Yeah, or you can use calculator.
And then you can square root, which will give you 5. So
Yeah.
x is 5.
Is there another very similar number that when you square?
Minus 5.
Yeah. Now, let's cheat and we will be punished for doing so. 10, 4 plus 2. So I'm just doing exactly copy-paste question. Now, if you're stuck in the exam, you do what you got to do. However, shift equals 2. Shift solve. Lucky 7. Roll the dice. So we get 5. Problem is, using this method, calculator returns the first answer. Do I tell a lie? What calculator are you using?
FX991EX.
Let's break out the graphical.
Okay.
Let's break out the graphical. Okay, graphical. So I can make this. Oh, I better. Do you know how to do the equations with this one?
I think so, yeah.
Oh, great. Okay. I don't have to make it look better then. I will eventually. But just for speed. I think it's solve n. Maths. No. Exit. Option calc F4. Solve n F5. I think so. And then we log stuff. Where is log?
What's solve n for? I forgot it on the calculator, but like, what does it mean?
Solve the equation.
Okay.
Solve doesn't work for some reason. Solve n is the one that works. Where's the log button? Oh, there it is. Log. Okay. So log. Oh, how do you put in the base? I'm not going to put in the base. I'm just going to roll the dice on this one. Log 4.
Yep.
Plus.
Yep.
2 log x is to the left there.
Yep.
Squared.
Yep.
So, okay, equals is shift decimal point.
Yep.
2. I'm going to close the bracket and cross my fingers and press equals. So more solutions may exist. No, I'm not saying 5. It's not saying root 5, but it's not root 5, it's 5.
Yeah.
Yeah. It's because of this log thing. Alright, it did get us 2 answers. So usually, yeah, this one actually gets us all the answers. But anyway, alright. Oh, look at that. We have to do it manually. Oh, you snaked. Hold on. Right. Let's go back to terrible calculator. That I said was wrong. X is minus 5. If we put into the calculator, let me copy that. 2 log 10, and we said x is 5 or minus 5. If I put in minus 5, maths error.
Yep.
Log can't be negative.
So it has to be 0 or above.
Yep. I think it can't even be 0.
Let's check. 10, 0. Yeah, it can't be 0.
Yeah, because the graph is, remember these exponential graphs like that? They get close to it but never touch it.
Oh yeah, yeah. So the asymptote, right?
Yep. So x equals 5. Alright. Hey, GOA so.
Yep.
Alright. Let's try this one.
Okay. So there'll be 4 cubed on the left.
Yep.
Which would give you 64.
Uh-huh.
So it'd be log 5, 64.
Yep.
And then you do 2 minus 2. What?
Well, this is connected there. Bidmus, you can't subtract.
So you do minus 2 times. So it'd be log 5 minus 2.
I would do, if you're insisting, let's leave it as minus and just do what you did on the other side. And so that goes up there.
Yeah, okay.
So I put up positive 2 and left this negative. What we saw is if we bring up negative 2 and make that positive, it's the same thing.
Okay.
Okay, any idea what you do next?
Then do you multiply 2 by... no, you couldn't.
You probably won't believe it when I tell you, but you add a log x squared base 5 to both sides.
That just makes the left longer, doesn't it?
Makes the right shorter though.
Okay. So you get log 5, 64, plus log 5x squared equals 2.
Yep.
And then you can add 5x squared. Then you can multiply 64 and x squared together.
Yep.
Which would give you 64x squared.
Yep.
Log 5 64x squared equals 2. And then you make it it's equal to 64x squared, right? So you make it 5 squared.
Yep, well done.
So log 5 squared equals...
Not log 5 squared, just 5
It
squared.
would be log. Okay, 5 squared equals 64x squared.
Yep.
And then you can square root both sides.
Why do you always do that first? Do the easy thing first.
Divide by 5.
You're trying to get x by itself.
So divide by 64.
Yep.
which would give you 5 squared over 64 equals x squared.
Yep.
And then you can square root both sides.
Yep.
So it'd be square root of... So it'd just be 5 over 64 equals x.
Square root both of them. Put it in the calculator if you don't believe me.
Okay. Wait, so would you put it in as 5 root 5 squared over?
Yeah, it's essentially like square root of both sides like that. Square root of everything.
Equals x squared shift. I got x as a really long decimal number.
Let's see. What did you put as the square root thing?
I put square root 5 squared over 64 equals x squared.
I said square root everything. Like that.
Oh, everything. Oops.
Yeah. You basically square root both sides.
Okay. I don't think I can put a square root over the thing again. I have to like type it all out again.
What?
I've got 5 squared over 64 equals x squared, but I can't seem to fit the root over it.
Oh. That's fine. Don't put a root down, just press solve it.
Okay. 25 over 64.
Alright. And that's equal to x squared. What is x? Or square root it? What is x?
Do you have to make it equal to x in the calculator?
You don't have to make it equal to anything. You...
Wait, so x is 25 over 64.
You cheekdom. You are... You know too many methods. Right, if you insist. 5 squared over 64 equals x squared?
Wait, so you square root the answer, so it's 5 over 8.
Yes.
Okay.
5 over 8. You would get the same thing if you did 5 squared over 64. However, I must show you equals... no, what did I press wrong there? That one, alpha equals x squared.
Okay.
So this is what you were insisting, which is crazy. You would just square root it. So there you go. You get your 0.625, and if you press answer, that it will say 5 over 8. However, instead of lucky 7, I'm gonna go with shift solve unlucky minus 999, and I get minus that. That's because you've got plus or minus 5 over 8. However, what did we see earlier? When we got a plus or minus answer.
Yep. So it'd be plus.
It would just be the positive one, 5 over 8.
Yeah.
Because that there, well, can't be negative.
Yep.
Great. Don't overthink these. I've taught you too many things in my calculator. Let's see. Solve this one. This looks like something. Aha. All right. Yep. This is a good one.
Okay. Okay, so far I've made it'll be log to the log 5x plus log 5x squared, which equals 4.
Mm-hmm.
And then would that become log 5x cubed equals 4?
Yeah, you're right.
And then you'd get then you'd make it 5 to the power of 4 equals x cubed.
Yeah.
And then you've already got x. You won't need to divide by 5, would you?
Can't do that. You
So now you
want
just want.
you want x equals.
So first, would you just cube root both sides?
Yep. And so it would be the cube root of 5 to the 4. I think is it saying this is wrong though? Put into your calculator square root of 5 to the 4.
Square root?
Yeah, just square root. No. Yeah, you're right. Put the whole thing in the calculator. See if it gives you an exact answer.
So cube root of 5 to the 4.
Yeah.
That gave me 8.54 and then a bunch of decimal numbers.
And so not an exact value.
No, not an exact value.
Hang on, before I look at the answer. So this is log base 5 x squared. When you multiply them, you get x cubed equals 4. 5 to the 4 equals x cubed. I don't see what we've done wrong. That's why. Why would I do this nonsense? Alright, just to give you an explanation. That's the same as 5 to the 4 is the same as 5 to the 3 times 5 to the 1.
Okay.
And what's the cube root of 5 to the 3?
5.
Yeah, so it's 5. 5 cube root the other 5 to the 1, which is just 5.
Oh, okay, yeah.
5 cube. Why would you do that? Alright. Okay, next type. It'll get trickier. Yep. How about this?
Okay. So for this, would you multiply log 3 by everything in the bracket?
No, doesn't work that way.
Okay.
It's like square root. It's like, or sine, like the log of
Okay.
those things. Bless you.
Thank you. So would you need to make it like, but it's not equal. It's equal to 2, but like, if you divided them, it would be x divided by x, wouldn't it? No power to divide by.
Basically, it is this divided by this. Because it's
So x divided by x equals x.
No. So it's basically log base 3. So it's minus, so it's divided by
Yeah.
x plus 11, because it's in a bracket, x minus 5.
Oh.
Yeah.
So it'll just be minus 11 over 5.
No.
Don't the x's cancel out, do they stay?
If they had times or divide between it, so if it was x times 11, x times 5, times and divide, in reality this is like a bracket and you can't, because of bidmas, you'd have to divide before you add or subtract.
So would x, can you divide x by x? Would that be like...
No, you cannot. You have to solve it from here.
Oh, from there? Okay.
Yeah.
Okay. Okay, that makes sense now. So you do 3 to the 2 equals x plus 11 over x minus 5.
Yeah.
Okay. And then you would divide by 3 on both sides.
Why do you always say that?
But last time I said squared, like square root.
Okay, so you could square root both sides. Then you'd get 3 equals. We don't care what 3 equals. We want x
We want what
equals.
x equals, right?
Yeah.
So do we want... But how do we get x on one side?
I would times both sides by the denominator.
Oh, so it'd be 3 squared times x minus 5
Yeah.
equals x plus 11.
Yeah. X plus 11. And then this one is 3 squared times x minus 5.
And then would you do 3 multiplied everything in the bracket?
Yeah.
So it'd be
3 squared.
3...
3 squared.
Would it be 3 squared x?
Yeah. What is 3 squared?
3 squared is 9, so it'd be 9x.
That's it. Hang on. Just continue with that. I'm just going to close this door. These kids are noisy.
Okay. 9x. Yeah.
Sorry about that.
It's fine.
Yeah. What did you get there?
I got 9x minus 45.
Yep.
And then would you minus 9x, and you could minus x on both sides.
Yep.
Which would give you 8x minus 45 equals 11. And then you'd add 45 on both sides, which gives you 8x equals 56. And then you'd divide by 8 on both sides, which would give you 7. So x is 7.
Great. And I was kind of expecting a plus or minus. That didn't happen. X is 7. Yep. Okay. Another one. That's similar.
Okay. Okay. So it'd be log 3 2x plus 5 over 4x minus 1 equals 2. And then it turned to 3 squared equals 2x plus 5 over 4x minus 1.
Mm-hmm.
And then you divide by 4x minus 1 on both sides, so it'd be 3, which would be 9 brackets 4x minus 1, close brackets, equals 2x plus 5.
Mm-hmm.
And then you multiply 9 by everything in the bracket, so you get 36x minus 9 equals 2x plus 5.
Mm-hmm.
And then you can minus by 2x on both sides, which gives you 34x minus 9 equals 5. And then you add 9 on both sides, which gives you 34x equals 14. Then you divide by 34 on both sides, which gives you x equals 14 over 34.
Okay, so let me see. 7 over 17. Yes, 14 over 34 is 7 over 17, isn't it?
Okay.
Yep. Half the top, half the bottom.
Yeah.
Great. Good. And once x is no longer in the denominator, and I'm certain that it's not going to be a quadratic, I can stick it in the calculator, because then I'm only going to get one answer.
Yep.
Let me just see. I'd love to. Let's see. All right, let's try A.
Okay. So once as a quadratic.
Just
work it out. Just
Just
work out the
solve
question.
it, I think, yeah.
Okay. So it'd be log 2, and then x plus 5 over... Actually, no. There's a 2 on the log, so you need to multiply 2. Wait, is it multiply, right?
It is.
Or do you square that? No, it would be brackets x minus 1 squared.
Yeah.
And then can you simplify the bracket? Can you expand it?
You could. Let's see. So that's equal to 1.
Yeah, it's equal to 1.
What could you do next?
You could do 2 to the 1 equals x plus 5 over brackets x minus 1 squared.
Yeah, and then
you could divide by the denominator on both sides, so it'd be 2 brackets x minus 1 squared equals x plus 5.
Yep, you fully expand, make it equal to 0, and you should get that. I think you'll be fine.
Yep.
And then how would you do part B?
Wouldn't you just do the same as you did before? It's the same question.
Okay, you'd get the same thing. 2x squared minus 5x minus 3 equals 0. And it says hence. And so how do you solve it?
I'm confused. It's the same question.
The solution to this question will be the same as the solution to this question, because they're the same thing. And so if I just gave you that as your starter, how would you solve that?
Oh. You'd need to break up the quadratic.
A level. Why did I send you that fancy calculator?
Graph.
So you wouldn't have to break up any quadratic. A is 2, B is minus 5, C is minus 3. Can you use simple calculator? So it's the same thing.
So you solve as a quadratic.
Yeah. 2 minus 5 minus 3.
I got x is 1 and x is minus a half. Well, no, x is 3, sorry.
So are those the answers?
No.
What's the answer?
You need to make it equal to... So it'd be minus 3.
X is 3. You would reject this negative answer.
Oh, right.
Because it can't be negative.
Yeah.
Let's see. X is 3. Alright. Well, anyway, that's it. Laws of logs. What do you give yourself?
Between a tick and a half.
That's alright. Yeah, how was that for you, Adam?
That was great.
And so, continue this next time?
Yes.
Grand. Any questions in general?
So, is 14.5 halfway through chapter 14, right?
Let's take a look. 14.6. See, it's going to go quick, that one. 14.7. 14.8. It's over half.
Okay.
Yep. I'll see how we
And
do.
then after this, we'll be doing statistics or mechanics first.
Usually mechanics first, I believe.
Yeah.
Yep.
That's what the school does, I think.
Yeah. It's what's kind of recommended. It's how it's laid out.
Yeah. Yeah.
Any other questions?
No.
Yeah, I'm keeping an eye on where we are and everything. Like one of the chapters in mechanics can kind of largely be skipped. It's just a kind of explains it, like a rod, a cone, not a rod, a particle, but there's no real questions as such. Yeah.
Yeah.
Any other questions?
No.
All right. Well done, Adam. You did great.
Thank you.
I look forward to talking again next time.
You too. Bye.
Cheers. Bye.